Hello all. Today's video is completely on Apache Spark. Okay, why we need to learn Apache Spark? What are the advantages of it? And why it is very necessary and why it became very revolutionary product in data domain. So these are the topics that we are going to discuss, but it's not the basic video. Okay, we are going to cover so many in-depth concepts and all. And when you need to learn Apache Spark, at what time you need to learn Apache Spark, and once you have covered your Apache Spark, then what you need to do, what you need to learn. So these are the things first we'll discuss, and then we'll go into the Apache Spark video. Okay? Yeah, recording is fine. Now, start. Now, so many people, when they want to step into data domain, they directly learn this tool, which is what we call it as a Databricks. Okay, so many people they will directly learn this Databricks and all. They will get lot of sophistication between them, and they couldn't able to understand what is happening in the industry and what are the things. If question was changed a bit, they couldn't able to understand anything. So many people, what they will do, simply they will what we call it as do Databricks directly. They will go and work in Databricks and all. That's not the efficient manner at all. If you want to work on Databricks, there are some prerequisites are there. Okay, there are some prerequisites are there, and you need to know why Databricks is there. That is the most important thing that you need to understand first. Okay, so let me remove this Databricks. So first of all, if you want to survive in this data domain, first there are two languages are there that you need to learn for sure. The first one is the Python language, second one is the SQL. You need to master these two particular things before you stepping into data domain. Okay, so I think my what we call it as students already know how to code in Python and how to write SQL queries and all. So once you are comfortable with these two steps and all, then you need to first understand something called as Spark, Apache Spark. I'll tell you why this Apache Spark. See, in a regular basis, if you see, the data is growing rapidly. Okay. We'll discuss about Apache Spark in detail. Why? Because this video is completely based on Apache Spark only. Okay. Why we need to use Apache Spark in the short terms, if you need to say, it is used to handle the big data. So Apache Spark is a framework that we use to handle the huge amount of data. Okay, if we are having lakhs of records, crores of records, our data is there in GBs and all. So at that time, we'll use this Apache Spark to manipulate our data, to process our data efficiently from one end to another end. Not only to process our data, it is used to retrieve the data as fast as possible. Just a minute. Sorry, let's start. So it is used to retrieve our data. It will process our data from source to destination, as well as it stores the data in an efficient manner, and it retrieves the data whenever we want any particular record in a very fast manner. Okay, but Apache Spark is not the first product. Before Apache, there are few products were being introduced and they got failed. And with the revolutionize of those things to fix those problems and all for the Hadoop and all, some products are there between. We'll discuss about it. The Apache Spark has born. So to fix the problems which are there in the big data technologies, the Apache Spark has born. Apart from that, okay. So once you are comfortable with Python and as well as SQL, sorry, once you are comfortable with Python and as well as SQL, happily you can learn Apache Spark. So you can watch this video. Even if you don't know Python and SQL that much, if you know okay also, still this video is for you. Okay. So once you are comfortable with the Apache Spark, okay, where we will run Apache Spark? The Apache Spark is run on top of Databricks. Okay, one platform is there. Okay, there is one platform is there, that is what we call it as Databricks. So on top of this Databricks we run Apache Spark. So this is what the overview of our Databricks and as well as Spark. So once you are comfortable with the Spark, see, there is no separate thing like first I need to learn entire Apache Spark, then I will do Databricks. No, not like that. We will learn Apache Spark on a platform. The platform is called as Databricks. Okay, of course, Databricks have some separate commands are there, but most of the 99 percentage of the time we use Spark only on top of it. That's it. Okay, and in which language we will write? For suppose if we are writing in Python language, we call it as a Python. If we are writing queries in SQL, we call it as a SQL. Okay, in Databricks, which language we will use to write the code of this Apache Spark? Okay, we use the language called as PySpark. PySpark. PySpark is a combination of Python and as well as Apache Spark. Okay, we use Python language, okay, to write the code, to process our data, to transform our data from one end to another end. So that's why we call it as PySpark. And there is one more thing called as Spark SQL. Almost it is similar to SQL only. Okay, similar to SQL only. So we use these two languages in Databricks platform to write code to Apache Spark in Apache Spark. So the language that we use to Apache Spark is PySpark and as well as Spark SQL. Okay, and what is a Apache Spark? Apache Spark is a big data framework. Big data framework. Okay, I hope you understood why we need to learn Apache Spark. Okay, before that we'll know few things that why this big data is being growing very rapidly. Okay, if you see in our olden days, okay, if you see in our olden days, what used to happen in our olden days, tell me. Okay, before going into olden days, let us discuss what are the topics we need to cover in this. So these are certain topics we need to cover. Okay, before coming to these topics, okay, I'm going to discuss about how traditionally our data used to be there in data, what we call it as SQL databases and all, how they used to manage that one. And what are big data processing engines? Okay, why these Apache Spark, Hadoop, MapReduce, why these things came, and what is a monolithic and distributed computing engines? Okay, and as well as what is Hadoop? Okay, what is Hive? How Apache Spark got evaluated by resolving the problems of Hadoop and as well as Hive. Okay, and as well as what is Spark architecture, and what are the computes and what are the clusters, what is the evolution of Databricks, how Databricks is been evaluated. So these are all step by step things we need to learn. And Spark context, Spark session, RDDs, lazy evolution. See, I don't have space, so that's why I didn't mention few more topics are there that we need to discuss. Okay, apart from that, rest of all the concepts are a pure knowledge. Okay, so do not skip the video anywhere. Okay, so try to take the notes, because the concepts are very easy to understand, but for sure you will forget everything within the span of 1 week only. Okay, so take the notes. Okay, and enjoy the video. That's it. Okay, now what is a traditional method of storing the databases? How are traditional people they used to store in the databases in 19th century and all, early years of 1980, 1990 and all. See, at that time there are not that much big data is not there. Okay, big data is not there that much. Big data means huge amount of data. See, today's world, everywhere, for each and everything, like Amazon is there, so it is selling huge amount of products. How much data warehouses they need to maintain, and how much data they used to consume. For every small thing we are keeping something called as we are consuming the databases and all. Blinkit, Amazon, Swiggy, all the things, for every small things we are using somewhat of some online application which stores the data behind our scenes. Okay. Now, what is a traditional method? See, at the when we don't have smartphones, leave about smartphones also. Before that also, in 1980s, around at that time. So generally, uh, before that, when computer was not there, how they used to store the records? Everyone know they used to maintain some files. Okay, let us take. I have some rice go down. Okay, I'm having one accountant. What that accountant will do? What that accountant will do? Every day that accountant will write the whatever the calculations are there in the files, right? Whatever the things are there in the files, simply what he will do every day, if you see. Okay, where are these things? Yeah, see, every day he used to generate few files. Okay, so whatever the accountant is there, if one book was completed, so he used to take the another book. Okay, one book is been completed, he used to take the another book. If another book is been completed, he used to go for another book and all. And where he used to store all these things in a shelf. And if books are keep on increasing, he used to take one room which is also called as a data warehouse. For the kind information, what is a data warehouse? See, data warehouse is where we dump all our data, which is in an structured and as well as organized format. Okay. Example, library is a data warehouse where it consists of books from start to end, and it is easy for you. If library, if you want to read engineering third year books, okay, librarian will simply say go straight and take left, then you will see one shelf or database. From that shelf or database, you can see some tables will be there. So from that you can take the book from that shelf. Okay, so how librarian used to know that? Because the entire library is in an organized format, structured and organized format. Okay, so it is very easy to retrieve the data. It's not only to store the data, it should be very fast and easy manner to retrieve the data also. Okay, so that is what the data warehouse simple meaning. It's a what we call it as data warehouse is a place where we dump our data, but that data will be in a structured and organized format, so that everyone can retrieve that data very fastly and everyone can read that data very fastly. Okay, so this is what about data warehouse. Now, in the early stages, they used to what we call it as store data like this. Okay, but but right now, what we call it as when computer used to came, when SQL language used to came, everyone know what is a SQL language. Okay, SQL language means, see, there is one SQL database is there with me. Okay, within the SQL database I am having some set of four tables. Okay, four tables I'm having. So in every table I'll store uh, each and every kind of records which are there in the format of rows and columns. Everyone know. Yeah, see, this is a user, this is me. Okay, if I want to, if I want to retrieve the data, if I want to retrieve the data from this database, from these tables, I use something called as SQL. So that's why I told that you need to understand SQL very well before coming into this data domain. SQL is a backbone of data engineering. Okay, now this is what the traditional methods. Okay, fine. But with the rapidly growing data, with the data is getting is grown very rapidly and very fastly, how long you keep on including your things in a computer? Okay, example, you are having one computer. Okay, already I have structured it. See, there are two kinds of approaches how you will handle the big data. Okay, there are two kinds of approaches are there. Big data means, see, every day you are getting some amount of data you're storing in computer, keep on storing in computer. Okay, you need to handle that big data, how you can handle that big data. Okay, okay, there are two kinds of approaches are there in this. Okay, there are two kinds of approaches are there. One is monolithic approach, and second one is distributed approach. Okay, just a second, let me check once. One is monolithic approach and second one is distributed approach. This monolithic approach is a very old format of data approaching. Okay, what is that old format of data? Example, you are getting, okay, today I got 1 TB of data, 1 TB of data of some orders or something. So 1 TB of data I'm having. So that 1 TB of data has ordered my product. So those people who have ordered those products, I'm having the data. How I'll process this data and where I'll store it, because I need to store this data somewhere now. I can't delete this data. So what I'll do, I'll take one computer. Okay, fine. I'll take 1 TB hard disk and RAM. RAM, you need to understand what is a RAM and what is a hard disk. Okay. Uh, Hard disk, okay, let us understand about that. But first of all, 1 TB of data, if see my computer, I'm having 1 TB of data. I have taken one system. Okay, this is a hard disk shelf and all. Hard disk will, if your system wants to have so much amount of data, if you want to increase your system space and all, there is something we'll use. I'm not that much aware of the name, where you'll keep so many hard disks and all, one by one on top of another. Okay, but it's very costly. Okay, I have taken one hard disk of 1 TB and I have taken RAM of some 4 GB like that. Okay, good. But what happening means, my 1 TB was completed on that day. Okay, fine. Next day, what I have done, this is my first hard disk. Okay. Next day, I have purchased one more 1 TB hard disk. Okay. And as well as I have next day, I have got some 500 GB only data this time. Okay, I have got only 500 GB data. Good. So I have just processed my data over here. But you need to understand one thing, when you're processing huge amount of data and when you are giving the workload to one system only, the system will not work accurately. It will be very slow. The performance of the system will be very slow. And whatever the data, if you want to see for a particular customer or anyone, okay, it is very hard for you to, it will take a lot of time to retrieve the data for you. Basic common sense example, uh, everyone, almost all of us are using Android phones only. Okay, or generally what is our RAM 8 GB RAM we used to handle, and as well as 256 GB internal storage, right? They used to give like that. Okay, fine. Now what is a major problem over here is, so whenever your data is getting full, okay, out of 256 GB, okay, your data is almost getting full of 250 GB, 251 GB, 252 GB. At that time only your phone will give an indication for you, boss, delete some files or transfer these files to somewhere. If you are not transferring these files to somewhere and all, it will definitely, your performance will go slow. If you see your performance when your phone is not having data, your phone will be very slow. If you want to open one single app also, it will take a lot of time to open and your phone will be stuck. Everyone knows this. Okay, in that case we are handling only 256 GB, but you are giving 1 TB, 2 TB, 3 TB data every day to a single system. Would you think that that system can handle these things? Definitely not. Definitely not. And it will hang. And second most problem in this is, if my system will fail, if my system will fail, my entire data is gone. Hard disk will be there. Okay, I need to process in another system and all. But if I want to process, I have got some. what we call it as again 1 TB data. This time I have got 2 TB data on a specific day. Okay. On that day, I need to process this 2 TB data to my system. If my system fail, how my system will process this 2 TB data? Absolutely not. It will not process it. So this is what the things. Okay. And before going into this systems and all, you need to understand what is a RAM and as well as what is a hard disk. Most of the people know, but people who don't know about it. Okay. Let us take an example like hard disk is your study table. Okay, let us take a study table. On your study table, and beside your study table, you are having your shelf where you keep all your books and all. Okay, let us consider shelf is a disk, hard disk, and your study table is a RAM, random access memory. Okay, how it is like, if you want to for suppose if you are using if you are reading science every day, science textbook every day, you are using the science textbook every day for somewhat of some reason. Okay, for suppose if you don't have RAM, okay, if it should have, okay, every time what you will do uh, you are studying, you're taking your science book from the shelf, studying, keep it in the shelf, again coming out and doing some things, again going to the shelf, taking the book again, sitting in chair, studying, again keeping it in the what we call the shelf, bookshelf and all. Does it consume time, right? Yeah. Why RAM means, RAM what it will do, initially you will keep your books on top of table only. Okay, you'll keep your books on top of table only until you study, until you use your application and all. Whatever the data or whatever the textbooks or anything is there, that will be stored in RAM. Okay, for a temporary manner. Okay, so you will keep your books on top of your table and you will read it. Okay, if you are having some other books to study, if you are doing max and all, okay, once you completed max, if your book science textbook is there on top of your table, it is easy for you to grab that book and as well as to read, rather than going to disk, rather than going to hard disk, or rather than going to this particular or bookshelf, taking it all, it consumes some time. Every time you need to get up from the chair, go over there, so it takes some time. So performance issues, those are performance issues. Instead of that, you keep the things on memory only for some time. So if the memory is getting full, okay, if your table got full having lot of books, then you will keep the things in the hard disk, or then you keep those books in the shelf. That is what how generally the things works. So whatever the data you are processing, okay, whatever the data you are processing in the Apache Spark and all. Okay, let us discuss about Apache Spark, but it's I'm a bit overexcited. Okay, sorry. Now, so so this is this is what all about monolithic computing. Okay, it is all about monolithic computing. Monolithic means mono means only one system will be there. You keep on increasing the hard disks, RAMs for the systems, but there will be one point where you can't add anything. Second thing, lot of performance issues will come. Okay. Third thing, retrieving of the data very hard. Fourth thing, fault tolerance. It's not at all a fault tolerance. Fault tolerance means what? If my system will get failed, data unable to process anymore. Okay, this is what about monolithic computing. Okay, now let us discuss about what is distributed computing. So in distributed computing, okay, uh there is the team Apache. Okay, it's not Apache Spark, team Apache. Apache is there during the time of 1990, at that time 1995, at that time I don't know the exact dates and all. Okay, what they have done is they have told, boss, every time, okay, if you need to process 1 TB of data, why you're processing every time and what we call it as giving this to one system only? You're not getting any performance issues or what? The first thing they used to ask that one only. So what they have done is, see, increase the number of systems, increase the number of systems. Okay, in each and every system keep 1 TB, 1 TB. For example, it's not 1 TB, it's more than 1 TB only. Okay, 1 TB. And as well as another system also keep 1 TB, 1 TB data. Okay, if I'm having 1 TB data to process, so I am the user. Okay, I'm having something called as 1 TB data is there to process. Okay, to process. What it will do, see, initially, I'll discuss about it. Okay, uh, before that, if I want to process 1 TB of data, what it will say is, boss, do not do like that. Okay, take four systems. Okay, one system you make it as a driver node. Okay, driver node. What this driver node will do, this driver node will distribute this 1 TB data among all the worker nodes. Worker nodes means these are slaves. These are also called as executors. Also, executors means if I want to process my 1 TB data, only these three systems will process, or these three worker nodes will process my 1 TB data. Okay, then what is the role of this driver node? Driver node is simply like as a team lead for this particular three worker nodes. What this driver node will do, this driver node will prepare a plan for you. Okay, and what it will do, okay, 1 TB data is there. Okay, you take some 250 GB. Okay, worker node 1 will take 250 GB, and worker node 2 will take something called as let us take 300 GB, or again 250 GB, and worker node 3 will take approximately 500 GB. Okay, it's not like that example I have told. Okay, so instead of processing 1 TB data to one system, it is processing 1 TB data to three systems. It is easy to process the data, and if I want to retrieve the data also, these three what we call as computers or three worker nodes will work simultaneously, and it will give me the data finally. Okay, in a very fast manner, because each computer having lot of space, lot of memory, and it is handling up to GBs of data only. It is easy to get. If you are getting more amount of data, if your data is getting rapidly increasing daily, 2 TB, 3 TB, increase the number of systems, that's it, or increase the number of worker nodes. Okay, so here we call system as a node. Okay, driver node, worker node. How these used to come? Okay, before creating this, there is something you can see, cluster manager. What is this cluster means? The group of driver node and as well as this worker node, we call it as a cluster. What this will do, let me tell you. Initially, I am the user. Okay, I went to something called as cluster manager. There are some cluster managers are there, like yarn, kubernetes and all. I go and tell me, boss, I need to process to 1 TB data. In future also, my data may get increased up to 2 TB also. I don't know about it. Okay. But but what you need to do, you create some systems for me and allocate it to me. Okay. Then what this cluster manager will do, it will first creates the driver node, and it will say, and it will give whatever the plan that I have given, it will provide that plan to the driver node, and it will say, boss, driver node, okay, you are there. Okay, this is a plan. The user wants to process the data up to 1 TB data he wants to process. What you need to do, as per the plan, the driver node will suggest me that I need this much amount of worker nodes to cluster manager. Okay, what this resource manager or resource manager means, who allocate members in the team, that's it. Okay, what this cluster manager will do, as per the driver node instruction, he will go and create the worker nodes. How many worker nodes are created, and he assigns all these worker nodes to the driver node, and he will leave. He will leave means what he will do, he will just manage the cluster that I am doing over here. Okay, Yeah. So he's managing the cluster over here. Okay, boss Rohit, you have told this is simply we call it as a distributed computing. The above we have seen the what we call it as monolithic, which is a vertical processing. Vertical means on top of every hard disk we keep on one hard disk and all. So this is what we call it a vertical scaling. Okay, vertical scaling means we need to upgrade the hard disk, we need to upgrade the mission, or we need to upgrade our things. Okay, there will be only one single mission. We keep on adding the hard disk on top of each other in a vertical manner, so that's why we call it as vertical scaling. That's it. Okay, what is this distributed computing engine? This is a horizontal scaling. What? Nothing like that, we keep on adding systems, that's it. Okay, then where this Hadoop map reduce came? What is this Hadoop? Hadoop is simply, we call it as a HDFS. Okay, HDFS. It is a very revolutionized product in the what we call it as in the data domain. Okay, it's a very revolutionized product in the data domain. Okay, what is this Hadoop means? Hadoop is a make a whatever I'm telling, please make a note of it. Hadoop is a open source framework. Hadoop is an open source framework that allows distributed storage. Okay, distributed storage, and it will do parallel processing of large amount of data sets across the clusters or across the computers. What is a parallel processing means? See, at the same time only, all my computers will run to perform a specific job or perform a specific task. Okay, if my homework is there, if I am doing my homework in my childhood alone, it is very difficult for me. At the same time, if my friends are also sitting beside me and they are writing my homework parallelly, means that is what we call as parallel processing. My homework will get completed very fastly. Okay, so that is what parallel processing. So Apache Hadoop is open source framework that allows distributed storage and parallel processing of large data sets across the clusters and as well as or across the computers. Okay, now what Hadoop uses? Hadoop uses something called as HDFS. HDFS, which is Hadoop Distributed File System. Okay, Hadoop distributed, because this is a distributed computing engines. So this is a Hadoop. This one, it will do like that. Okay, what it will do generally is Hadoop map reduce. Okay, let me go and tell you what is a Hadoop map reduce. Okay, okay, so what is this map reduce? Okay, what it will do means generally whatever the data I'm giving from the user side means from here. Okay, it will first of all map my data where that data needs to fall. Okay, so where my data 1 TB data needs to fall, it needs to map to the three worker nodes. Okay, so it will do three mappings for me. Once it is been done, what is reduced? See, once the data is been processed, it needs to collect the data from the systems, right? Okay, what it will do, from these three systems it will collect the data, or simply we call it as a reduce, and simply collects the data over there. Same, this is the same architecture of that one also. What it will do, whatever the data input I'm giving, okay, it will map as per my worker nodes. And finally, once all the processing is being done, data processing is a stage. Okay, one processing is being done, it will reduce the data, reduce, not, it will not size or anything, it will collect the data from my endpoints and it will give to the output. That's it. So if anyone asks what is a map, okay, what is a Hadoop map reduce? It is same like as a Apache Spark only. We'll discuss Apache Spark later on. Okay, what it will do, it it is also a distributed computing engine. Okay, what it will do, it is used to map or distribute our data across the missions. So how many missions are there? It is used to map or distribute the data across the missions, and these machines are responsible to process my data. And once it is been done, it after once we need to collect the data from the machines, so it is used to collect data from all the machines and it will provide for you. That's it. So apart from that, nothing is there. And what is a main architecture? This is a main architecture of this Hadoop MapReduce. Okay, this is a Hadoop MapReduce. MapReduce is used to distributed processing. It is responsible to distribute the data and process the data. HDFS is a Hadoop data file system. In this Hadoop data file system only we store all our entire data. Okay. And Yarn have done, it's a cluster manager which is there at the beginning. What it will do, it will create the computers for you, engines for you, computed engines and all. And it is also a resource provider. And what are the jobs are there, it will schedule. You will understand what is a job after this. Okay. Hadoop common, these are some utilities. Every thing will have its own utilities and all. Okay, leave about it. But your main concept is to understand what MapReduce will do, what is HDFS, and what is a yarn. Yarn is also not that much important. It is a kind of thing. Okay, and what are the most important things in Hadoop? First of all, if you want to store your data for storage, we use something called as HDFS, Hadoop Distributed File System, and as well as to do processing means from my driver node, from my user to my systems of end processing. What I'm using something called as map reduce. Map means to map my data from my driver node to how many executors are there, those many maps I need to do. And from those executors, I need to collect the data. That is what we call it as reduce. I hope everyone understand on this. And to do the management of these clusters and all, we use something called as not only yarn, we use this something called as Kubernetes also. Okay, that's it. Okay, so this is what all about Hadoop MapReduce. Okay, but Rohit, you have told Hadoop MapReduce is going fine. And what is a language that we use on top of this Hadoop? See, like I have told in the beginning of the video, that for Apache Spark, I use something called as PySpark or something, right? PySpark is a language where we used to take Python as a PySpark. If I combine with Python, and I use SQL also languages to write the PySpark code. Okay, what I will do in Hadoop? What is a language I need to use in Hadoop? There is something called as Hive. We use something called as Hive. This is what the language we use. It's also called as Hive SQL like that. Okay, Hive SQL like that. What it will do means whatever the our big data is there. Okay, whatever our big data is there, this Hive SQL. This is what we call it as Hive SQL. It is kind of a SQL query, not exactly like SQL. Okay, it's a kind of SQL query. Whatever our big data is there, it will convert that entire data. It is this is used as a Hive SQL, and it will process my data in kind of a SQL language. Okay, that is what we used for Hive. So what it will do, Hive, it converts whatever the our map reduce, that whatever I have done into my job. Okay, into my job. And why we use this Hive, all these things. So it is a data warehouse tool. Hive is a data warehouse tool. Simply I need to say Hive is a data warehouse tool we use in Hadoop. Okay, why we use Hive over here? Okay, why we use Hive over here? So it is a data warehouse tool. It is a system where the big data is used to run as a SQL query. Okay. whatever our big data is there, it will run as a SQL query. It's not exactly SQL, but it runs like as a SQL query. There is something called as Hive SQL, separate language is there for that. Okay. So what it will do, if I'm having 20 lakh records with me, what Hive Hadoop file system will do, it uses something called as Hive over here. Okay. It is used query the records like as a SQL layer. That's it. Okay. Example, if I am the user, okay, I will pass something called as Hive SQL over here as my data context. Hive SQL as a data context to it. Okay. Or it is also called as Hive context also. Okay, now this whatever the SQL code that I have given, this will get converted into my map reduce, and that map reduce will create as a Spark job, and it will execute the result and provide it to me. That's it. Okay, if I want to understand these things in depth, like see, if you want to understand this a bit more, like see, first of all, I will pass, first of all, whatever the user is there, whatever the user is there, user will pass the data in the Hive SQL format. Okay, it then after that what it will do, it will create something called as Hive context. You will get to know what is Hive context, Spark context and all. Context means nothing, it is a starting point of the Spark, or it is starting point of the that particular HDFS. And after that what this Hive context will do, it will convert it into map reduce. Map reduce, it will map and reduce the data. The entire process of doing this map and reduce is called as a job. This is a job running for me. Okay, and finally it will execute by worker nodes, execute by more worker nodes, and finally it provides a result to me. So the language that I use in this particular layer, in this particular Hadoop map system, or Hadoop distributed file system, is Hive. So this is what all about Hadoop. But you can ask me a question that Rohit, everything is going fine now. Then what is this Apache Spark came on top of it? Okay. See, Hadoop has failed after some time. Why it was failed means, see, every time when I'm giving 1 TB data to my system, it is directly going and storing in the disk. It is directly storing and going and storing in the disk. Okay, storing in the disk. Because of that, what happening means, see, this is Hadoop is simply, if anyone asks what is a Hadoop, you can simply say it is a disk based processing engine. It is a disk based processing engine. So whatever the data that I will give, that data will be stored in the hard disk directly instead of storing it in the memory. Okay, because of that what happened means, whenever I want to fetch any data, very large amount of data, it is taking lot of time to retrieve that data to me. When I'm querying everything, it is taking lot of time to retrieve the data to me. Okay, that is where Hadoop has failed. To fix this issue, Apache team has sat and they are fixing this issue. On top of this Hadoop layer, we got something called as what we call it as Apache Spark. Okay, this is what the Apache Spark. Apache Spark is a next level of Hadoop. Okay, what Apache Spark will do, Rohit, over here, it is same. I can see the same kind of structure over here. Yeah, it is same kind of structure only. But Apache Spark is a memory-based distributed compute. What it will do generally means, whenever I give the user, if I give anything to driver node, whenever I'm working anything, first of all, the whatever my data is there, it tries to store the data in my memory. If my memory is getting full, then only it will go to disk and it will store the data over there. Example I have told now before, the science textbook. If I am reusing my science textbook again and again and again and again, better to store that science textbook in memory only, because it is there on your table only. So whenever you want, quickly you can take and refer your book. But every time going into shelf, disk and taking your book is not an efficient manner, right? So first of all, the Spark tries to store the data in memory. Once memory is getting full, then it will go to the disk and it will store the data. Okay. Now leave about Databricks for some time. What is the Spark architecture over here? Same. This is a cluster. Databricks. It is a cluster manager. Okay. Same like before we have seen. Okay. Same distributed engines only. There will be one cluster manager will be there. You go to cluster manager and you will say, I am having some 4 TB of data to process these things and all. Some, if you are having 3 worker nodes are there. For suppose if you are having 3 TB of data to process, okay, if you are having 3 TB of data to process, okay, you will go to what we call it as to um, cluster manager, and you will define how many driver nodes you need, how many worker nodes you need. So first of all, the cluster manager will create the driver node, and once as per the driver node plan, the cluster manager will again create this worker nodes, and it will assign all those worker nodes to driver node again. Simple. Leave about Databricks. I'm not talking about Databricks. I'm talking about Apache Spark. Okay. Apache Spark is a in-memory processing. Okay. It will read the data in RAM. So because of that, 10x fast it will happen for me. Okay. And iterations means what? Before in Hadoop system, and now we've come to Apache Spark. Hadoop, if for suppose I'm having very long queries there, I'm having that result. Okay. If I want to reuse that query again, if I'm using that query again and again and again and again, okay, Hadoop will again run the same query again and again. Means it will again iterate the same query again and again, which costs more and performance low. Okay, it's worst for iteration tasks. Okay, same steps it will read again and again and again and again. But it's not like that. Spark. It creates something called as DAG. DAG, I will explain what is a DAG. Okay. It creates something called as DAG means a plan. Okay. And if I'm having any result or anything, it store it somewhere and it will use it. It will use the result instead of running the entire thing. Okay. This is one of the future in the Apache Spark. Okay. So what is Apache Spark? Hadoop failed to fix the Hadoop issues and all. They have come up with a revolutionary product called as Apache Spark. Okay, what are the code that we use? As I have told before, we use something called as PySpark and as well as Spark SQL over here. That's it. Okay. Now, now, what is this Databricks then? Okay. See, Databricks is a platform that you need to run your Apache Spark. Okay. For suppose if you have set up your Apache Spark manually, right? If you have set up your Apache Spark manually, right, it is very difficult for you to uh, manage the clusters and all. As I have told now, this is a cluster. This is a cluster. Okay, this is a cluster. And what it is doing, Apache Spark, what Databricks is doing, Apache Spark is easy to what we call it as it is just like as a we use Python. We won't run Python idly. We use something called as VS Code on top of it, right? It is just like to run our Apache Spark, we use something called as Databricks on top of it. But Databricks is not only for that. Okay, Databricks is a UI platform. Okay, it is used to if I want to, for suppose before that, let me tell you one thing. If I have set up my Apache Spark manually, okay, I need to set up a cluster. First of all, everyone know cluster means what? how many worker nodes and how many driver nodes are there that I need to set up and I need to merge it. So all those team will become a cluster for me. Okay, that I need to do. And as well as I need to manage my cluster on my own only. That is also my headache. Third thing, if any configurations are there in cluster configurations or any kind of driver node configurations, any changes are there, those things also it's my headache only. I need to configure those things manually and I need to scale manually, and it is very hard to debug also for me. Okay, because of all these things, Apache has created someone called as Databricks. He is basically cluster manager. Simply he says, boss, you do not worry about all those things. Okay, you just concentrate on your code writing part and all. Cluster managing, okay, creating the clusters and as well as managing the clusters, scaling the clusters, configuration of the clusters, I will take the part. I will take a part of it. You do not worry about anything. I will do everything automation. As per the requirement, I will configure the things. That's it. This is what the revolutionary product that came, Databricks. And on top of Databricks only, within the Databricks only, we'll run our Apache Spark. Means we create our cluster and we'll leave it to Databricks. Databricks will manage all our clusters and all necessities. And this is a data lake. Finally, whatever the data is there, I will store it in the data lake. Okay, I'm not here to today discuss about Databricks. Okay, of course, I'll show some basic UI of Databricks and all. Okay, but what is the sequence that you need to learn is, first of all, you need to have some knowledge on Python and SQL. Not super candid. You need to have some knowledge on Python and SQL. If you are having knowledge on Python and SQL, watch this video. This video is purely based on Apache Spark only. Once you have done on Apache Spark, you will get some idea on Databricks simultaneously. Why? Because we are running Apache Spark in Databricks. Okay. So, so now, now I have created my Azure account. Okay. All the students know how to create my Azure account. Okay. I have already explained this part many times. So no need to explain this part. It's waste of time. Okay. Now, after creating the Azure account, okay, I'll go to my resource groups, okay, as well as I'll go to my project. So when I came into my resource groups, okay, I have configured these three things, okay. One is storage account, okay, and as well as Databricks access connector, okay. Everyone know these things also. If I want to use my storage account, I can't connect from Databricks to storage account. I need something called as access connector. I define role for this access connector in this particular storage account, and I will give the resource ID which is there of the ID card of this access connector to this Databricks. So indirectly Databricks will access the data in the storage account. Okay, but here also to learn Apache Spark also no need to take from storage accounts and all. Okay, first of all you need to understand what are the concepts are there. Okay. Mm, so I'm launching my workspace. So I hope everyone know how to set up these things. Okay, I have already explained these things in the classes. So this is my Databricks portal, okay, the cluster manager, okay, where I'll run all my Apache Spark and all which are there inbuilt in this. Okay, now let us have some basic idea about it. This is what about workspaces and all. How many works I have? Two workspaces. Means the workspace means the space where I am working. This is my accounts tab. Everyone know. Okay, now let us concentrate on this thing. Okay, there is something called as, you can see, compute over here. I told now, first of all you need to create a cluster. What is a cluster you want to create? Okay, here I'm having two clusters. I will show you what is a cluster we need to create. Okay, cluster means, see, already if you need to just create on compute. Okay, if you want to learn Apache Spark much better, okay, do not create on this simple form on, just keep off of the simple form. Then you can see the exact options and all. As I have told, it is asking me you need multi-node or you need single node. Multi-node single node means, see, simply to say, let me come down. Here it is asking how many nodes you want. Okay, if I click on multi-node, worker nodes and driver nodes both are separate. In general cases, in the payment account, see, if you are, this is my Azure free account. Okay, so here for me, multi nodes are not support for the more amount of cores and all. Okay. Now what I'll do, if you take multi nodes, there will be one driver node will be there and there will be some worker nodes will be there. So first of all, let me tell you, if I click on multi nodes, it is asking me about on what runtime I need to do. So this is what the virtual machine generally. Okay. Keep this off, not needed. These are all cost. And it is asking me how much is each worker node having for you. Okay, each worker node having for you, just remember this: 16 GB, 4 cores. I will discuss about the cores. Okay, this is a basic one that is available. So total worker nodes are 16 GB. So worker nodes are 16 GB and having 4 cores. So you need to define how many minimum worker nodes you need, maximum worker nodes you need. Simply if you take one worker node, it's enough, because we don't have that much amount of data to do parallel processing among the machines and all. Okay, fine. Now what is a driver type? Driver type also you need to define as it is. You need to give it is same like as a worker node. Driver type is also same as a worker node. Yeah. Enable auto scaling. It will, if I give this one, Databricks will auto scale these cluster related part and all with respect to my requirement. Okay, then once this is been done, I need to give, okay, once whatever the cluster or whatever the compute I'm creating, it should get terminated after 20 minutes if I am not using it. Okay, if everything is done, click on create compute. But if you have ran this compute, it will not work. Why? Because recently Azure portal, they have changed the quota limits. Quota limits means if I'm taking the free account and all, I'm not getting those many amount of worker nodes and all for me. Okay, instead of taking multi nodes, if you want to learn Spark and all, just take single node. Single node means, see, there is single node is nothing. There will be no separate driver node, no separate worker node. Both driver node and separate node both acts as single node only. Okay, I'm taking only one node. If you take this node, this will work for you for sure. Okay, and what is a Databricks runtime version over here for me? So the Databricks version runtime I'll take same. And if you are using single node, see here it is not asking about the worker node, so driver node again. It is asking only one time what is a node type. Node type is standard DC4 ASV4 V5. This one. Okay, 16 GB, 4 cores. That's it. I'll explain about what is a course and all, because you will understand. Course means it just like as a one partition or one task or one partition is given to one core. That's it. Okay, you will get to know what is a partitions and all. Same like of I need to give 20. Nothing you need to do. This will work for you. You first of all switch off this simple form off, select single node, give your whatever this particular name is there, you can provide that one. And after that you need to give this particular how many, what is the Databricks runtime, you keep it as it is, do not move anything. Turn it off, use photo acceleration, it is not required. Why? Because it will consume your whatever the Azure 200 credits that was given as fastly. Do not give those things. Terminate after 20 minutes, create compute, that's it. Okay, once you have created the compute, see, it will show like this. Okay, this is my compute that I have created. See, same like as I have given, nothing I have done. Okay, so once you have created your compute, okay, you need to attach this cluster. See, if simply I need to say what I have done, I have set up this entire system right now. Okay, entire system I have set up. Now till now what I have done, I have set up this entire system. What is a driver node, worker nodes, all these things, right? Now what I need to do, if I create this compute, it is enough? No, it's not enough. Okay, what you need to do, you need to, this is what the cluster that I have created, right? Cluster, sorry, this is what the cluster that I have created just now. In this I have given only single node, which means the driver and worker will be in one only, so both will execute only single thing, that's it. Okay, now if you come over here, if I create this one, nothing will happen. I return my code, so my code will be written over here, right? I have wrote some code over here, something called as uh, read my file some SQL query, select star from some from that particular table. So I have wrote some code. Okay, if I have wrote some code, I need to attach my cluster to this particular notebook. I need to attach my cluster to this particular notebook, so that whatever my notebook is there, whatever my notebook is there in this, okay, it will use my, sorry, it will use this cluster to process the data code that I have given in this. Okay, I hope everyone is clear till now. Okay, now now let me come to my Databricks. So this is what all about compute. Okay, let me start my compute. Okay, because it will take hardly 2 to 3 minutes of time to start the computes and all. Let it start. Okay, now what are these? Before going to jobs and pipelines, I told I will write my code. Here I will write my code. Okay, here I will write my code. What I need to do in this workspace, I need to create. So I need to go to workspace. Okay, I need to go to repositories or anywhere you want. Okay, simply go to home. Now, simply what you need to do, there are so many things that you can create and run. There is something called as folder. Within the folder, you can create all your notebooks. Notebooks means nothing. Uh, if I have told na, to note all the Apache Spark notes that whatever I'm telling right now, so you will keep it as a reference, and whenever you want to process the data, you will read that notebook. Same like as notebook is a, it's a Jupyter notebooks basically. Okay, it is a Jupyter notebooks. What these notebooks will do, okay, Apache Spark, I will name my notebook Apache Spark simply. This is Jupyter notebook. Here I will what we call it as write all my code and all. And here I will see, I'm having Rohit cluster. I'm having there is one more cluster, it is not showing. Why? Able to auto complete, go to compute. This is starting. Okay, this is still starting. So once this is done, I let you know. Okay, so my compute has started. Okay, just now it took me about hardly 5 to 6 minutes to start. You wait for some time. Okay, it will get started. Now if I go to my workspace, if I go to my this one, okay, just attach your notebook to the cluster that you have created. See, there are two more clusters are there. If you have seen this, what we call it as, no, 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 not this one. Why code assistance unavailable, unable to complete? Yeah. So just refresh your tab. Okay, you will get to attach this one. It should be in green color, then only it got attached. So once your work is done, you can terminate this. Okay. What is serverless? See, serverless compute, it is given by Databricks. Recently, it got launched. I think last year it got launched. See, you do not need to create any compute, but see, you can't learn on serverless compute. You can learn PySpark coding and all, okay, but you can't learn serverless compute. How actually Apache Spark behaves, how data processing is being done between the what we call it as executors, between the driver nodes and all, how DAG is been created. So many things are there that you need to understand. There is one more cluster I have created, but that cluster I'm not using it right now. Why? Because that is a normal cluster. Okay, I can't see that. Okay, now I have attached my notebook. What I can do, I told in Databricks you can use so many languages. See, you can write the things in your own language, Python, SQL, Scala, R, but I use Python and SQL only to write the code. The first thing is markdown. Markdown means to give the heading. Heading. See, first of all, if I want to something called as creating Spark session. Okay. So this is what the first markdown. So you will just first of all write the markdown. What is a markdown means? It's heading. Now this is a code. If you give this one, it's a code. Defaultly it is there in Python. Okay, you can change it over here by coming to default language, but let it be in Python. Okay, so this is what all about workspace. You will do like that. If you keep on increasing your notebooks, you can increase your notebooks. Okay, let me duplicate this tab. I do not want to disturb that one. Okay, now we have uh, learned about workspaces. In workspaces, you can see I have told you can create a notebook. This notebook I have created. There is something called as SQL query. This one also you can create. So if I click on SQL query, if I click on this SQL query, or if I click on this SQL editor, both are same. Okay, here also there is something called as uh, SQL starter is there, SQL warehouse starter is there. See, if you go over here, this is a SQL serverless starter. Here also you can create a warehouse, SQL warehouse. It's not the warehouse I have told like database warehouse means where I store all the data in an organized format. No, no, no. It's a compute. It is also a cluster to execute the SQL queries. It uses only pure SQL codes. Like we have seen something called as notebooks before now. Like where I can use Python, where I can use SQL, where I can use Scala, R languages. It's not like that. If you create this compute is only used to write the SQL queries only. That's it. Apart from that, you can't do anything for that. And this particular session is only used to query the tables data. That's it. If you are having any files data and all, sorry, it will not give. Okay, fine. Now let me go to this particular compute over here. Now, if you go to compute is done, recent tab, nothing. Recently, what notebooks you have operated, it will show those notebooks for you. Okay. Catalog. This is the most important thing that you need to know. Everyone know what is a catalog. Everyone know how to set up the meta store and all. Okay. In classes, I have discussed those things. Okay. What is a catalog? Catalog will create and it will do a unity catalog. We call it as a unity catalog. So it will just within one unity catalog I can create n number of databases, and within one workspace I can create n number of unity catalog for the data governance purpose. Okay, see, I have created one catalog. See, I can create one, I have created one sample catalog over here. Okay, within the sample catalog I have created one more schema, which is this one. So basically, this is my meta store, which gives the additional information about all my data and all. Everyone knows this one. This is a meta store. This is a catalog. Okay, in catalog, it is showing, okay, these things are there for you. Okay, within that, if I want to create a schema, I can create a schema. Already, I have created one schema morning. Okay, this one. And after that, here in the schema, it is showing four things for me. Leave about models and functions. There are two things are there, tables and as well as volumes for me. Okay, what I can do with this? What is tables? What is a volume? Simply to say, table is a structured organized format which, if the data is there in a table format, if the data is there in table, so that where I'll store all the things in tables. If my data only these tables only I can use here to query, I can't use volumes. Volumes means unstructured data. Okay, what is unstructured data? Means unstructured data means, see, tables are structured format. Okay, volumes are unstructured format. Okay, there are two things are there. One is tables, and the second one is volumes. Volumes. Okay, volumes, these are simply tables which consist of rows and columns. Rows and columns. What volumes consist of? Volumes consist of, volumes consist of, like, these are CSV files. Okay, JSON files. Okay, Parquet files. Parquet files, etc. Example to show. Okay, I have already shown this for you, but for your reference I'm showing. See, there is something called as employees table is there for me. Okay, but see, I don't have CSV formats to open in my laptop, so defaultly it will open for me in Excel. If you keep just see the properties, my file is in CSV format. CSV format means what? It's a volume. It is a volume, right? Or it's a unstructured data. But when I'm opening it, I don't have any CSV formats and all to open in my system. So defaultly it will open in my Excel, showing it in what we call it as in rows and columns in a table format, right? But now see, if I close this file, okay, when I go to my this one desktop, if I just open this one and preview it, see, this is the same data. I can see how it is exactly, it is there in CSV format. CSV means comma separated. Okay, see, all my, these are all my column names, but it's not behaving like column names. The first row will be taken as first column, comma, second column, third column, fourth column, fifth column, sixth column, like that it will go. Next row, first column, second column, third column, fourth column, like that. It keeps on adding the things. So because of that, in the industry level, we use mostly the CSV formats. Why we use CSV formats? Why? Because to reduce the size of the file, and it is easy to process the data within the systems and all. If I process the table formats and all, tables are also fine, okay, but CSV formats are much better to process my data. So that's why in the initial stage, when staging areas and all, they used to give the raw data in the CSV formats only for us. Okay, now, and that also depends upon the uh, company guidelines. We can't decide. Okay, now, where I need to upload my data, I need to upload my data in this particular volume. And see, I have created one volume and named it as sample. Okay, if I click on this sample, if I click on this sample, I'll get two files. I have given employees.csv, and this departments.csv. Okay, and as well as volumes, this is my path where my notebook needs to come and read this particular one. And one more thing, I can't read these volumes by using SQL queries because these are not tables at all. Okay, now I hope everything fine. Now come to over here. Okay, now what you need to do, first of all, you need to understand, okay, what is an RDD, okay, what is an RDD, and as well as what are the things that will happen, what is a Spark session, what is a Spark context. See, now in this era we are not using any Spark sessions and all, but you need to understand what is a Spark session. Okay, Spark session means, see, if you are organizing, if you are writing your code, there should be some auditorium or something. See, if you are organizing any event, there should be some there should be some what we call it as some medium, right, like some auditorium. Or let us take an example. If you are listening to my class, okay, what is a medium between that? If we have scheduled our Google Meet class every day and I'm teaching you the lessons in that, there should be some session, Spark session. What is that session over there? The session is nothing but this particular Spark session for me. So whenever I want to write any code or anything over there, so this is a session that is used over here. But in the beginning stages, they use something called as Spark context. Okay, they use something called as Spark context. What is Spark context means? See, they use something called as, they used to write in Spark context. So what is this Spark context? Spark context, it is an entry point of Spark. Okay, this is a entry point of Spark. This is a entry. No, 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 no. Okay, what is a Spark context? Spark context, it is the, it is an entry point of Spark. Okay, what it will do, see, whatever the code that you write, so you used to write your code in the Spark context and all. This Spark context will connect to your cluster. Okay, Spark cluster. Okay, and whatever the execution is there, whatever the code execution is there, it starts from here only, starts from Spark context only. Okay, this thing we used to do in the olden days, in the beginnings era where it is used to come. Okay, and where we use this one, we use this for RDDs. RDDs, I will explain what is a RDD. RDD is a resilient distributed data set. Okay, I'll explain that one. Okay, how we used to declare the Spark contest. I used to take SC is equal to, I used to write Spark context. I need to give the something called as what is my where it is running, Spark context, and what is a that context name, my app. Okay, so this is what happened, and this Spark help context helps you to create the RTDs. I will explain what is a RTDs, but you just make a note of it. Okay, but later on, the Spark context was replaced by this Spark session and all. Okay, what is a Spark session? What is a Spark session? Spark session, we used to establish a Spark session. I have told before, like if I am using something called as what we call it as one medium to connect my code to the cluster, I used to create Spark session. Okay, how we can create a Spark session? It is very easy. It is very easy to create Spark session and all. First of all, just a minute. Yeah. So first of all, to create a Spark session, you need to import. See, for this, you need to have some basic PySpark coding. Okay. If you don't know PySpark coding and all, you need to watch the PySpark video that I have post, or you need to have the notes. Please listen. The PySpark class is very neat and clean. If you don't know PySpark coding, so you can't understand this Apache Spark, because to write the things we use something called as Apache Spark, the PySpark language to in this Apache Spark. Okay. First of all, you need to import the Spark session. To import the Spark session, you need to write from PySpark dot SQL import Spark S capital Spark, okay, session. First of all, you need to import it. If you ran it, see, successfully it will run. Okay. Now you need to create a variable called as Spark. Within this variable, you need to create a Spark session first of all. To create a Spark session, how you can create? First of all, you need to write Spark session, because you have imported dot builder. I'm building, this is Spark session builder dot app name. What is the name that you want to provide for your Spark thing? So I will provide something called as read my CSV. Read my CSV. I'm just telling read my CSV. After that, what I need to do, I need to give dot get or create. So get or create my Spark session. So if I ran it, now my Spark session will get created. Okay. If I have given Spark, okay, if I ran it, okay, I will get whatever the Spark session that I have created over here. Okay. But see, the app name it is showing as Databricks shell. But you have given Spark name as read my CSV. Why it is giving Databricks shell? Because see, because there is, I have told the Spark context now. Spark context, first of all, it will write the Spark session Hive, and as well as this one Spark context, it is giving Spark UI. If you click on this one, it will take to the Spark UI separately. That's a separate thing. Okay. You will get to know stages, so format, executors, all these things. So here in the you can see what is things and all. Okay. Now, but see, by defaultly Databricks, every time the people are creating Spark is equal to Spark dot session dot builder app name, all these things everyone writing. So by defaultly what Databricks has done is it had created one variable Spark, and it had or built one Spark session, already established one Spark session for us ready. So if I print Spark na directly, see, without giving anything, if I ran all, see, it will run successfully. See, it has given Spark, but I haven't given anything. But Databricks, by default, it has established one Spark session for me. Okay, so it is showing what is a version v4 local master, and what is the name it has provided. It is a Databricks shell. So in the before stages and all, we used to create Spark session, but right now I'm not creating any Spark sessions. Okay. Now the next concept is, there is something called as you need to know about. Okay. The next concept is, there is something called as you need to know about. Let me delete this one. Please make note of these points. Please pause the video, note these points. Okay. Now let me what we call it as, you need to understand two concepts. One is RDDs, RDDs, and versus data frames. This is a one of the most hot topic. Not hot topic. It's a very important topic. What is a RDD and what is a data frame? RDDs are something like resilient. RDDs are something like a resilient distributed data set. Resilient distributed data set. Okay. What is this RDD means? See, simply whatever the data that you are having, it will store it in a format. So that is what simply we call it as RDDs over here. See, for suppose how we can write a basic RDD, and I'll tell you what are the RDDs that we can do over here. Okay, see, a basic code of RDD I'm having or not. Yes, see, if I want to create a RDD, okay, RDD, see, simply, but before that, I'll show you how RDD stores the data. Okay, see, I'm having two records. Okay, I'm having two records. Take my name Rohit, and as well as for suppose take this one like this. Okay, and comma, and take another name Ratna. Okay, and take something called as 30,000. Okay, RDDs will store the data in the Python list. Okay, within that list, for each and every row, it will store the data in tuples. Okay, Rohit and 5,000 is one row. Ratna and 3,000 is one row. Okay, but the problem over here is RDDs, what you call it as, doesn't know. Okay, who you know or what in RDDs like Rohit, what is the column name of Rohit? Rohit is name or salary, or 5,000 is name or salary. Okay, RDDs don't know those things. Okay, it's a biggest mistake that RDDs are doing over here. Okay, so it is divided into tuples and list. Okay, RDDs doesn't know the meaning that Rohit is a salary, yeah, or this is a salary or what like that. Okay, but we use RDDs in our systems. Okay, resilient means what? See, whenever I create a RDD, RDD means simply to say resilient distributed data. So the name itself only it indicates that what is that resilient distributed data. Like, see, if I'm having uh, one table is there, okay, if I'm having one data is there, okay, this data, it consists of name, okay, and it consists of something called as salary, as I have told. Okay, now let me take my name only, Rohit, something called as 50,000 salary. Okay, Ratnamu, let me take something called as 30,000 salary. Okay, what this RDDs will do, for suppose if I'm having two computers with me, okay, two computers or two worker nodes, okay, with me, two worker nodes with me. What this RDD will do, this RDD will split the data, okay, into two parts. See, here only two rows are there, okay. Two rows will go into one RDD, one computer only, okay. But for your explanation, I'm telling, okay, what this RDD will do means, let us take few more rows, okay, for your understanding. Okay, if I have taken, okay, Ravi, okay, Ravi some 40, and as well as Santosh, some okay, something called as Srinu, okay, some 50. Okay, these are four rows are there for me. Okay, what this RDD will do, it will split my data. It will split my data, distribute my data. First of all, it will split my data into partitions. Partitions are nothing but small chunks. Dividing my data into small chunks or breaking my data into small parts. That is what partition. Okay. Now what this RDD will do. So this is a RDD. Okay. Let me check my video is running or yeah, it's running. Okay. Now, what it will do, it will split my, first of all, Rohit and as well as 50,000 in this first part, Ratnam, and as well as 30,000 over here. Okay. Now, Ravi, Ravi 40,000 and as well as Srinu 50,000. Okay, now what this RDD will do, it will first of all, whatever the data I'm having, it will split my data, these two data into one RDD, create one RDD, these two data into one RDD, and this data it will provide it to the executors for me. And these are what? These are the logical partitions. This is the partition one, first partition one. Okay, or let me write it for you. Okay, this is a partition one, and this is partition two. Okay. So guys, sorry, there was some small glitch happened. So because of that, I'm continuing this part again. So as per I have told, what are RDDs? RDDs are it divides or it makes the data into partitions with respect to required partitions, and those partitions it will transfer to worker nodes, or we call it as executors, or we call it as something called as yeah, machines, like that. Okay, so it will pass like that. Okay, you can see one partition. Let me write one small thing for you. Here there is one catch you need to do. Okay, in the before you can see that one partition one partition will go to one particular node. If one partition is go to one particular node, okay, and one core will take one partition. One core will take one partition, or we can remove one node also. One partition is equal to one core, or one core will run one partition, which means if you come to our Databricks account, my cluster is getting started. Okay, let me duplicate this tab. If I go to my compute, if I go to my compute, you can see this Rohit's cluster. So for this particular cluster, I am having 16 GB, four cores are there. One particular, what do you call it as? This particular, only one node we have created, single node as per the quota limit that we are having. So what it will happen means, see, if I go over here, so I am having how many cores I'm having? Four cores I'm having. Okay, which means let me come down. Okay, if these two are making one partition, okay, and my particular what we call it as, my particular thing consists of four cores each. Okay, here I am having total, I'm having only two, but here I'm taking only one node. Okay, I'm having only one node. 16 GB I'm having, and four cores. Four cores means each core will take one partition, which means if I'm, for suppose, if I'm having, let us say, um, I have created one data which have eight partitions are there. Like this, four people, I'm having eight partitions. Okay, eight partitions I'm having. Okay, if I'm having eight partitions means my data got divided into eight partitions over here. Okay, that's good. But now the thing over here is, if I'm passing this to my core, whatever the what we call it as, my particular system that I have created, I'm having only one system, Just a second, a glitch is happening. Okay, yeah. Sorry, one small glitch happened. So let me copy. Only I'm having one system. Okay, this single system only will act as driver node and as well as executor also. Executor also. Okay, so when this system is working as both the things, this particular system, my system having 16 GB, 16 GB and 4 cores. 4 cores. 4 cores means what? Means see, each and every core will take one partition, which means see, let us create uh, core 1, core 2, core 3, core 4, like that. I'm having 4 cores. Okay, these 4 cores are having in my system, which means what it will do, it will take a, it will take a partition 1, partition partition 1, okay, and it will take partition 2, partition 2, okay, and it will take partition partition 3, and it will take partition 4. There are 4 partitions it will take, but what it is doing means at a time these 4 will do parallelism. Means I told it will do parallelly, it will run all the partitions. So I am having 4 cores, so whatever the 4 partitions I have taken from this particular my particular data set, it will parallelly, it will execute, it will run 4 partitions at a time. And what about the rest of the 4 partitions? Because out of 8 partitions, I'm having only 4 partitions I have taken. So the rest of the 4 partitions will be there in the queue. It will wait for some time to read the data. So in this period, it keep on loading the things. If my work needs to get faster, what I need to do, I need to take one more system and same 16 GB and 4 cores I need to take. So if I take like that, so at a time 1, 2, 3, 4, 4 partitions will run in 4 cores, and in the other system also 4 partitions will run. So at a time my task will get completed. So this is what distributed things and all. Okay, this is one more thing, resilient data distributed data set. Okay, this is what resilient distributed data set. Okay, here there is one what we call it a small I think one small formula will be there for it. See how I can decide my things and all. And one more thing you need to understand over here is, see, one more thing. Okay, what is that thing, Rohit? One partition equal to, okay, one task. One partition equal to one task, and that one task will be executed in one core. One task will be executed in one core. So this is the first thing you need to understand. Okay, so we'll discuss about the partitions or how we can do partitions and all in real time scenario. um, do not worry about it. And you need to understand how the code flows also. Yeah, now when we are discussing about the partitions now, we'll discuss How, sir, Rohit, how we can discuss the number of how we can give number of partitions and all means? See, if I want to, even I can create my own partitions also. Partitions is equal to or is directly proportional to 2 to 4 2 to 4 into total course. So like that I can decide my partitions. So I can take 2 into total course. So 2 twos are 4, right? 4 twos are 8. So I can make 8 partitions, that is fine. 8 partitions, that is fine. So it depends upon the performance of the things. So this is what about the RDD. Okay, what RDD will do. So these are the things that RDD will perform in front of you. Okay, now let me pull down. We'll discuss each and everything uh, while performing in Databricks. Do not worry about it. Okay, now as I told, what this RDD has done over here, it had divided my data into small chunks. Or RDD is a kind of list data type, but list can do partitions and distribute the data. And this list, whatever the RDD is there, this can do partitions and distribute the data among the missions. Okay, so this can do partitions and distribute the data among the missions. But if you write code in RDD, see this one, what we call it as our data frames couldn't able to, and see, first of all, Spark couldn't able to understand the meaning that what are rows, what are columns. This is how you write in RDD actually. Okay, but Spark couldn't able to identify this one. So that's why, to make it simple, we came across something called as data frames. Data frames. Okay, what is a data frame? See, data frames are built on top of RDD. Okay, it is built on top of RDD. How means, see, just what we will do, because every time whatever the RDD you are writing, the columns and rows, it is just having Rohit 50,000, some Ratnam 40,000. And how Spark will get to know that Rohit is a name and this 50,000 is a salary? It will not get to know. So that's why what we will do, we are creating a data frame on top of it. Okay, what is a data frame? Data frame is a distributed collection of data organized into named columns. This is, data frames are distributed collection of data organized into named columns. So whatever the RDD we are having, or whatever the data we are having, we are providing columns for that. So to make it in an organized format. That's it. That is what the data frames. And to build a data frame, we use RDD, because see, we need the data also to build data frames for sure. So what we will do to build the data frames, we use RDD. Data, sorry, this is very important. We use RDD. Okay, that we have used before. Okay. So actually, in generally, how RDD is been created in the before early ages. Okay. For suppose, uh, in generally, like RDD, first of all, it starts with RDD dot dot. For suppose, if I want to filter my salary greater than 50,000, okay. First of all, I'm writing in RDD. I will write filter. I will use here every time RDD uses lambda function, lambda, some x, this one, and as well as x of list of first value, okay, should be greater than 50,000. If I write like this, okay, the Apache Spark couldn't able to understand, okay, what is this 50,000? What I need to execute? Okay, inside Lambda, what we call it as what happens, Spark doesn't know anything. What happens in the Lambda function? Why you are writing 50,000 like this? So it couldn't able to understand. This is what simply writing in RDD. What I will do, I will create a data frame for that. So if I create a data frame, now data frame will be created df dot. I use filter. This is PySpark coding. Okay. So I will give the column name salary. That should be greater than 50,000. So if I give like this, the Spark will understand, okay, this guy is referring salary, and within the salary, he want to take more than 50,000. So this is major difference between the RDDs and the data frames. Okay, we need RDDs, but on top of RDDs, we built data frames. That's it. I hope everyone understood this thing. So I think we have stopped over here. Like what is a Spark session and all. Again, I have imported the Spark session, and I'm just writing Spark. See, if I write Spark, okay, Spark will what we call it as see what Databricks have done is every time Spark is equal Spark dot builder, as I have explained before, it won't do like that. They have created a variable, and in that variable they have stored the entire session. So by default the Databricks have created one session for you, so you can use the Spark variable to create a data frames and all easily and happily. Okay, now first of all, let us create what we call it as this data frames. Okay, later on we can discuss about what is a DAG and all those things and all. So as I told that before, over here we'll create something called as data frame. How data frame has been created, that is what the major thing. So if I want to create a data frame, what I need to do, I need to first of all let me take some data over here. Okay, so Uh, till now we have discussed about this one. So now let us enter to how to create the data frames, how data frames are being created. Okay, let us take for an example. I am having a data, something called as data, which is there under a list having two columns. Okay, one is Rohit, first this one first record, comma, and as well as the second one is something called as, let me take 50,000. Okay, this is the first record. If I want to take the second record, I will write Ratnam, comma, something called as 60,000. Okay, so there are two records are there in my things. Okay, if I want to data frame, I told we need something called as columns, right? I need something called as columns. So I need to create a columns is equal to, now I'll give the column names. Okay, what are my column names? My column names are two names only. What is name and as well as comma, the second one is salary. So column names. But now how I can integrate these two? Okay, but how I can integrate these two? So first of all, I'm creating a variable df. Df is not a data frame yet. Okay, this is a variable. Now whatever the Spark which I have used above, I am using it. So it will create a Spark session for me. Dot, I need to write something called as create data frame. Okay. Now what I need to do, I need to give the rows first and as well as columns next. See, if I do data comma columns. Okay. So if I give data comma columns, or if I give instead of that, for your convenience, I am writing rows. Okay. And here also I will write rows. If I write like this, okay, my data frame will get created. Okay. Okay, I need to again start and attach it and run. Okay, let it start. Okay, let it start. We'll wait for some time. So my cluster was started. So if I run, click on run all. So see, my data frame was created. Okay. See, if I have done this data, okay, but I couldn't able to see any of my data. You see, there is something called as one data frame was created, and it is showing the name is string and salary is long. Okay. Databricks have its own capacity to give its own data types. Okay, which is also we called as inverse schema. Okay, but how you can watch the data? Okay, see, Databricks have something called as one concept called as lazy evolution. Okay, Databricks have not Databricks, Apache Spark have one concept called as lazy evolution. Okay, what is that lazy evolution? See, whenever you run anything, see, there is something called as action commands are there. There are some action commands are there. Till you give that action commands, the Databricks or this particular Apache Spark will not run the entire code. Whatever the code that you are keep on giving to this Apache Spark, it keeps on adding that to a plan. That's it. Okay, let me show you how it works. Okay, let me just what we call it as come nearby. Yeah, see, what happens is I wrote some code over here. Okay, df is equal to I wrote some code over here. Okay, but it haven't do anything for me. Nothing happened. It has shown that okay, fine. What this particular Apache Spark will do, it has something called as concept called as lazy evolution. Eval Evolution. Okay, what it will do now, see, whatever the transformations you are adding, okay, whatever the transformation, for suppose, see, I am having three transformations I have done. Okay, the first transformation is I have created my data frame, and some there is some data is there. Okay, what I have done, so what is my transformation? What is my transformation? Transformation one is transform one is what I created data frame. Okay, what it says? Okay, boss, you have created now. Okay, fine, thanks, no issue. Okay, sorry. Okay, it will say okay, boss, you have created now. Okay, fine, no issue. Now, second time it will come one more thing. Now it will say you have created data frame. Okay, second time what I have done, I have read the data transform to. Okay, I have read data from some file. Okay, read underscore employees file. So employees file I have read. Employee file I have read. Okay, okay, it will say okay, fine, super. Nothing it will do, nothing it will do. Again, one more transformation. Transformation 3. This time what I have done, whatever the data frame I have created, I have added new record to it. Okay, Databricks say okay, fine, done now. Okay, fine, nothing it will do. It keep on doing like that. I will that one also I'll show you for you. Okay, that one also I'll show you. Okay, what is the last one? Let me take one more transformation I'm doing. Transformation. I'm just what I'm doing. I'm filtering it out. Okay, filtering. Uh, Salary should be greater than 60,000. Okay, then out of I'm having three members only. one member is came. Okay, one member will come. What is the output that I'll get finally? That is Ratna. Okay, fine. I say, okay, boss, you have added four transformations out of it. Okay, for four transformations, I won't get anything. Data Apache Spark will not do anything. What it will do, it keep on adding this to a plan. One, what we call it as one transformation, another transformation. Nothing it will do. This is what we call as a lazy evaluation. Until and unless we give something called as an action button, it won't do anything. What is that action button? Okay, see, let me do over here. Let me append one more what we call it as record in this. Okay, so to append one more record, what I'll do, I'll take rows. Not like that. Okay, what I'll do, I'll write it to a file. Okay, I'll create a file in volume, or I write it to the file. To write it to a file, what I need to do, I do df dot, because in this data frame only I have stored my entire data, if you see. So what I'll do, df dot write dot option. See, this is a PySpark. I will explain about the PySpark in the later videos, okay? Or listen the class very carefully, you'll get to know. Okay, header true, okay. And what I am doing, header true, comma, mode, mode. Mode is I am writing something called as override, or let me write append. What I'll do, dot CSV. Let me give the file path where I want to store it. Okay, if I want to store it in catalog, sample catalog, Spark schema, and within the Spark schema, I want to I'll create one more volume, which is a final something. I want to store my records in this final. Okay, create. So if I click on this final, this is my path. Okay, within this volume, I want to create a CSV file. Okay, CSV file, and I want to store it in this. That's it. Okay, let me run this one also. Okay, it is taking some time. If not, sometime you need to write the entire notebook and all. Okay, so it ran. Nothing happened. Nothing happened. One Spark job created. Okay. I'll tell you what is Spark job. Okay. Now I want to add one more record. Okay. There is one more person came, Kiran. Okay. Now this time what I'll do, rows to one more new variable I have taken. Within this variable, I am storing two more persons. Let us store Kiran, comma. Let us give some 56,000 salary. Okay, comma, and let us add one more person. Okay, yeah, Kumar, fine, good, 65,000 rupees salary. Okay, 43, that's it. Wow, fine, 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 not required, not required, not more than this, it is required. Yeah, so this is what the three persons I'm adding again. Now what are the columns I will take? The columns I will take column 2 is equal to. Now what are the columns? I'm having only two columns, name and as well as salary. Okay, now see, now again what I'll do, I'll create something called as df2 spark dot create data frame rows 2 comma columns 2, because rows and columns. If I run it, it creates one more data frame nicely. Okay, now what I'll do, again append this data, to my where, to my that file. Okay, appended. See, nothing happened. See, if I go to my file, and if I what we call it as refresh this one, see, I'll get few files which got added over here. Part, all this one. Okay, but why it got added like that? And why it is not showing me any result? See, that is what the concept of the lazy evolution. Okay, what lazy evolution will do? What are all the transformations you are doing? So, for all those transformations, it will read it. See, if I want to read the file also, that whatever I have wrote it, simply I will write df3 is equal to something. I will write spark session dot read. Okay, what I'll do, let me do df equal to df3 equal to spark dot lead spark dot read dot what format, what is the format of my file, csv format, and option what is an option here. I want to make all the things header. See, I want to read how many files are there from this particular final catalog. I want to read all the files. Okay. See, if I have ran it, it had read, but it didn't show any values for you. So here, how many tasks I have performed? I have created a data frame. Okay. Then what I have done, I have write write the data frame, write the data, and again what new records I have done. Filtering I have not done yet, but what I have done, I try to read the data. Okay, now what I'll do, now I'll do filtering on top of it. What is a filtering? I'll apply something called as df3 is equal to df3 dot filter. Okay, what I'll do, where column of salary should be greater than, let us give 50,000. Okay, this is what my conclusion. Okay, but I haven't took the this thing. So whenever you will get to know all these things in PySpark code. Okay, from PySpark dot SQL import, what I'm importing, import PySpark dot SQL dot functions. Okay, import star all. Okay, let me run it now. If I run this one right now, okay, everything is done, but nothing happened. What it is showing, everything got added to plan. So initially what it will do means it will add everything to plan. Nothing it will do, it will add to plan. What is the next transformation I have done? I have filtered records greater than 50,000. So nothing it will do. Okay, now if I want to view my final result, I need to hit some action button. The action, I mean, there are some action buttons are there for me. Okay, there are some action buttons are there. There is dot display, dot show, whatever my data frame is there. I need to write df dot display to display that these are the action things. Okay, action button, df dot display, df dot show. Okay, and df dot count. Okay, df dot count and df dot collect. It just like whenever you have added everything in the plan, if you want to view it, you need to add this part for sure. I hope this one is fine for everyone. Okay, this is an action. So once you switch on this switch, then only everything, whatever happened in this entire plan, will be displayed for you. See, if I do right now, see, df3, the final data frame is df3 dot display. Okay, if I ran it, see, I'll get data like this. I think two times Ratnam got added. Second time also Ratnam got added. Kiran Kumar Suresh, whose salary is greater than 50,000 rupees, they have came. Okay. I have added all the people over there. Spark dot read dot format CSV, this one. Okay, see now df3. Okay, here also df3. Yeah, okay, let us give df4, df4. Okay, let me run all the tasks. Why I get all the ratnam values? 60,000, 60,000, 60,000. Mm-hmm. But where are the other people? Okay, okay, okay. See here, I have wrote df which I have created before that value I have done. Okay. So initially I have created data frame df. So that value I'm df dot overwrite I'm doing. Fine. Again I am writing. Okay, fine. See the issue. Let us see. The issue over here is, see, I have created rows. Df in variable. I am storing rows and columns of Rohit and Ratnam. Good. Now, if I come down, I have write this to my this final folder. It got saved. Okay, fine. After that, I have created again one more rows and columns. There are Kiran Kumar Suresh data is there. df2 is called spark.create data frame rows 2 columns 2. This is also fine. But again, I need to append this data. But again, I am overwriting my first data only. So that's why I am getting Rohit here for Ratnam here for 2 times. Okay, that's it. See, if I run it again, this time no error will come. Let me try to run. Now this time see the people who are there, Kiran, this one, Kiran, Ratnam, Kiran and Kumar. These people came. Okay. But the thing over here is Spark creates, I told now Spark creates some plan. The plan is nothing but this is what we call it as a DAG. It's not DAG also. It's a plan. That's it. It keep on acting everything in a plan. Okay. Next, what it will do, Spark does not do anything over there. Okay, does not do anything over there. Okay, now here the problem over here is whenever the code runs, whenever I run my code, let me come down. Whenever I run my code, okay, whatever my driver node is there, right? Driver node is there, na? It creates a DAG. Okay, it it creates a DAG creates. Okay, and it not creates a DAG also. First of all, it adds to the plan of plan of all the transformations. First thing it will do. Okay. After that, what it will do? After that, what it will do? Once we have created this, all the plans, nothing until end, it will not do anything. So you have seen until and I have given action command, it haven't performed anything. Okay. But first of all, why it will not perform anything means Apache Spark knows about himself very well. Okay, it will not arrange the code that how I have wrote it. Okay, it will optimize the code. For suppose if I wrote this one, for suppose this should come before, this should come after, it will not tell anything to me. First of all, okay, you keep on adding everything in my plan. What I will do is, once you get the hit action button, okay, your driver node, if I give action button, okay, our driver node will create a DAG. DAG means directed a cyclic graph. What is this graph? This is a plan that how my entire notebook code is getting executed one after another. Okay, how my notebook code is getting executed one after another means, see, if for suppose I have wrote this to read over here, for suppose, actually I don't know because I don't not know Spark that much. Okay, Spark know about himself now. If this should execute before, Spark will execute, it will rearrange all the cells that I have done and it will optimize it. Then it creates a plan for me, bro. This is a plan that this is your notebook plan. Okay, DAG is something called as blueprint for the notebook. Blueprint for the notebook. And what based upon this DAG only, 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 my sorry, based upon this DAG only, my RDDs will create create partitions. So it will partition my data, and after that, what it will do, whenever it creates a DAG, the driver node, the driver node, once DAG is been created, one job will get created over there. Before creating the DAG, there will be one job will be created. See, immediately when you hit on action button, so one job job will be created by driver node for me, driver node. Okay, driver node, immediately one job will get created. And what this job will do, it this will what it will after that, uh, in within the DAG it will show that okay, what are the stages and tasks that need to be performed. I'll explain what are the stages and tasks. So once it will create the RDDs and all, so it will create stages, and as well as it will create tasks. Tasks I have already told, these are the partitions that we are assigning to a executor. So finally it will execute over here, then it will display for you. So these all things will be performed, since all things will be performed when my particular executor will when you hit the action button. That's it. When you hit the action button, then only you will get all these things. Okay, see, I have done executed these things till I haven't, till I have given this action button, nothing happened over here. Okay, if I come down, see, one more thing. I told now there will be one job will get created when I click action button. See, this write is one action. Okay. Write is one action. Read is one action that we are doing. Write is one action. Read is one action. That is also action. See, for this particular data creation, nothing happened. Data frame creation. For this calls, I have write over here. So another job, another job. I have filtered it, nothing happened. Now I have displayed it, so it is showing two jobs over here for me. Okay, let me go to the last job. Whenever you want to go to this top job over here, you will get to see one new tab will get created for you, one new tab will be opened. So nothing, again I'm showing over here. Okay, again I'm showing over here. Just click on this job 18, job 18, and if you expand this one, you will get the others. Okay, so this is what the what we call it as data bricks. All the details you can see about the what we call it as what are your stages, what are your jobs, what is your storage, what is your SQL data frame. So simply go to SQL data frame over here. Okay, SQL data frame. So if you go to your SQL data frame, see these are all the list of jobs that we got created from initial to till now, from zero to write all these things. So it was being executed in an order for you. Okay, now if I click on this one, df.display, see what it had done. See, this is what the DAG, directed acyclic graph. See, simply what it had done, it had scanned my CSV. Okay, it had scanned my CSV. These are all the details. I'll explain about the details. No worries at all. Okay. So how many columns it scanned over here? Two columns it scanned over here. How many file it read? It read seven, what we call it as seven number of files it readed. And out of seven files, how many columns it scanned? Two columns it scanned for me. Okay, and come down, you can see the data size of all these things and all. So these are very simple things to understand. And if you come down, how many rows I got as an output? 5 rows, because I'm having 5 people are there. If you come here and if you remove this one, you can see how many people I have added. Initially I have added 2 people, after that I have added 3 people. So that's why it had read total 5 people for me. Okay, what is the size of this one? This is under bytes only, not that much. Okay, now if you come down a bit, so these are the normal things. Do not what we call it as worry about these things. But what you need to understand mostly is what are the sizes of the files, this one. Okay, and as well as how many outputs that you have got. You got 5 outputs. Okay, and as well as you need to come up and you need to see how many number of columns it scanned, 2 columns, and number of files it read is 7 files. Why? Because they got into some partitions over there. Okay, now come up, nothing to do, nothing to do. So once it has scanned the things, what it has done, it filtered the records, because I have applied filter on top of it. So how many rows got filtered over here? Because as per the condition I have given, 3 people are there. So these 3 people got filtered and I got output as 3 over here. Once I got output as 3, finally it collects in a area. I told now something called as initially map reduce and all. So it is a collect. What it collects over here, see, simply it is saying any corrupted merge blocks, nothing there, no fetch time, because this is a very small data set, na? So that's why. So nothing it will do. See, so whatever the any errors are there, nothing happened. So this is what the plan visualization for me. Okay, these are the plan tag. Based upon this plan only, based upon this plan only, here all the tasks will get executed. So whenever the job will get created. Once you hit the action plan over here, the job will get created. When the Spark job will get created, all the other things will go as usually. Okay, simply to say again, this is a quite bit what we call it as tricky one. Nothing will happen. See, first of all, this will store initially when I have stored all the transformations. It will store all the transformations in a plan. Okay, first thing. And it will only execute the code when you click on action button. That is second thing. Third thing, why it will not execute the code immediately? Because the code is not optimized. Spark understands better than us. Okay, so once we click on action, the Spark will rearrange our code and then runs then runs as usually. Okay, before that, before rearranging our code, the Spark will create something called as DAG. Based upon the DAG, the code will get rearranged and then it runs. So once we click on action, the plan will create a job which contains all the transformations on top of it. Okay, if you want to view the query plan, okay, if you want to view the query plan, so how query plan is going, simply do df dot explain, just run it. This is what the query plan for me. Okay, so what happened over here, it will show for this, not df, not df, not df. Df means initially, it is only showing that there is some existing rdd got created. Why? Because df is a rdd that I have created in the initial stage. No, I need to see the query plan of df4, df4 data frame 4. If I run it, see, it will show what df4 has done. See, first of all, it filtered all the records. Okay. And before that, what it will do? It will remove the duplicates on top of it. Is not null. Sorry, not duplicates. It will remove all the null values out of it. Okay. And as well as casting means it has done typecasting to big int. And after that, what it is doing? It will go from below to above. So first of all, it will scan the file of this one salary, and it will show if any partitions were there in this. So this is a path where my file is been getting stored. Partition filters, no partition filters are there. Once it is been done, then it will filter the records file. That's it. So this is what the DAG, and this is what how the physical plan works over there. Okay, so this is till now what about the DAG and all. Now let us discuss about partitions. I have already told about partitions. Partitions are created based upon the RDDs and all. Okay, so partitions are nothing but these are the smaller chunks of data. If I'm having large amount of data, see example, I'm having five records now, where for suppose if I do after appending, yeah, let me do df3 dot display. So here I'm doing action button. Let me run it. See, I have three jobs got created over there, and let me copy this. Okay, let me copy this and paste it over here. Okay, so this is my first of all one of the DAG. Okay, see, not DAG, sorry, it's a table for me. Okay, partitions are what? Out of five partitions, as you know, DAG will get created, and what it will do, it will take these three partitions, these three in one, and it will take these two partitions in these two records as one partition. Okay, this is one partition, and this is one partition. Okay, this is what this is partition 1, and this is what this is partition 2. That's it. Okay, when I give partition 1 and partition 2, so if I have run what we call it as these partitions, how these two partitions will get divided by with the help of RDD. Okay, so this is what this is a RDD for me, resilient data structure. And see, there is one more advantage is there from the RDD. When RDD will get created, once my Spark job will get created, right? Once my Spark job will get created, let me write the hierarchy again. Okay, when I give action button, when I give action button, driver node, driver node, okay, what it will do? Creates DAG, DAG. Okay, once DAG has been created, Spark job will get created. So Spark job will get created. Will create. What Spark job consists of? What are all the transformations that I have done? All those transformations will be there in that job. Okay, fine. Once all those transformations are there, then what will happen? Then what will happen? Then it will apply as per the plan, it will apply RDD or partitions on top of it, and then partitions will apply, and those partitions will go to executors to make the work. This is what actual task, how it flows, okay, from start to end. So these are the partitions that we do. And till now what we have discussed, and let me once give one neat code, okay. uh, when I have wrote df equal to code, okay, df is equal to code, I have wrote some code. This is my data frame I have created. So when I have give df underscore code, if I have meant this one, what I have told, the driver node, the driver node, what it will do, or what it will do, it creates a plan for you, okay. This is very important, so that's why I'm telling this these many times, okay. What it will do, it creates a dag, okay. Once dag has been created, what it will do, it will optimize or rearrange the code as per dag, okay. Once it is been done, then what will happen, so it will use something called a using spark engine, it will use, okay. Spark engine, it will then push this data to create something called as RDDs. Based upon that, it will create RDDs, means partitions. It will split those things into partitions, and it will distribute, wow, it will distribute these partitions to worker nodes. Okay, so this is how my uh, till now how this part will go. This is my worker node, worker node 1, no? So worker node 2, why, worker node 2, okay. Which means that whenever I create this code of tag from here, RDD will do like that, okay. For suppose, again I'm telling, if I'm having, if I'm having 8 partitions, or let me take 4 partitions, okay, 6 partitions, okay. Partitions, next concept is how we will perform partitions, individually we can perform partitions, that's one, okay. So if I'm having 6 partitions, if my this thing have, okay, let us take 2 cores are there for me, okay. Two 2 cores, okay, 2 cores are there, okay. If I'm having 2 courses, and I am having here also 2 cores. 2 cores means what? One core will take one partition. So here how many partitions will be taken? Out of 6 partitions, here 2 partitions will be taken, and it will run simultaneously. And here also 2 partitions will be taken. It will run simultaneously. Once these 2 data got processed, then the rest of the 2 partitions will go. So this is what about DAG and how DAG works, how to create RTDs and all. Now our next topic in our next coming video, we are not coming video, next only it will come. Okay, the video length has got very much high. We will discuss about how many types of transformations that will apply. Based on my transformations, how my data will change, and what are the steps do I need to do. So the class from here is very important, okay. Till here also it is very important, but from here it is very 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 crucial, okay. So kindly please, till here please read. If you are having any doubts, please contact me, I'll clear your doubts, okay. That's it, thank you.